It's another boring day here in Texas. What can I say? It's mid-August, and we're seeing a little bit of a altocumulus layer here outside. This was a few minutes ago. A little bit of mid-level moisture there, probably just drifted up from the Gulf. And here's the current map that we have right now. Looks a lot like yesterday. We're still slogging through this August weather pattern. Things are changing a little bit. Things will get more interesting as we get into September, definitely. But, as I've said over the past couple of weeks, this is giving us a chance to kind of shake out the bugs and the cobwebs and get a format going here for the stream. All right, so we've got southeast winds across Texas. That's the first thing that you should be able to pick up. And the other thing is that there's this indeterminate flow across Oklahoma. Looks like we got winds out of the east here and out of the south here, out of the north. So this is clearly not coming from the Gulf. This is probably some air back behind some thunderstorm activity up to the north. And if I look at the temperature values you see here on the right side of the screen, one thing I haven't talked about too much is the way to analyze fronts. The one easy trick you can do, and this works in the wintertime too, is what I call the imaginary car drive. So we start down here in southern Texas around San Antonio, and we jump in the car and it's 95 outside and we got a southeast wind. We drive all the way up to Waco, get out for some Whataburger or some Brahms or something like that. I don't know, do we have Brahms in Waco? I don't know, it's pretty far south. But yeah, we get outside and it's 99 with a southeast wind. We drive up all the way up to Greenville. Now it's 97, southeast wind. So you can see the air mass has not changed very much. In fact, it's the same when we get up to Paris, Texas. But once we cross the Red River up to Idabel here, you can see we drop to 82, and now we've got a north wind. So you can kind of use this technique to kind of mark where your front is. And it helps when you start from the warm sector, because the very first place you notice a change is going to be where the boundary is. So let's try that one more time. We start out here in Del Rio. It's 1/3 or over 63. I don't know how those people stand that kind of heat all the time. It's very dry down there in Del Rio. 101/57 in San Angelo. Cools off a tiny bit there at Abilene, but the winds are a little bit more out of the east. And there we go. Now we've got a north wind, and it drops off to, looks like 80 there at Seymour. So here we have another change. And you can see, like right here between, I'm not sure what town that is. This one is probably going to be, let's see, Mineral Wells. I think it's going to be Graham and Palo Pinto, somewhere in there. But we got a difference here between, and I'm losing my voice, golly. Let me mute this so I can clear this out real quick. Just a sec. There we go. All right, go from 98 to 85 here, and you can see there's a change in the wind direction too. So I can put that together bit by bit and kind of assemble where that boundary is. And it looks like there's a change out here in East Texas too. We pick up this easterly wind out here at Lufkin. It's a little bit cooler compared to this 97 here at Huntsville. So there may be something going on there too. 76 here at Marshall, I think. Bring that down. It looks like that connects up to the storm area near Lake Charles. So it looks like we've got a couple of boundaries kind of strewn across Texas, and if I go through I'll probably get something like that. And then sometimes on the back edge you'll also find a boundary. So if you find like divergent flow, you might be able to paint a boundary on the back side. I don't think I quite see that right now. Maybe a little bit off the map. But anyway, this kind of suggests that there's probably an area of thunderstorms across Oklahoma, like maybe some patchy thunderstorms, maybe some here. So that's kind of what's going on. And when we do a mesoanalysis, that's the process of finding all these little boundaries and drawing the showers on. I actually do that so I can keep track of what they're doing from hour to hour. I pretty much put everything on the chart as I go. And then out west, I don't think I see much of a dry line. We're not really going to see one this time of year. You can see it's pretty much backed all the way up to the mountains. There's 55 to 60 out here, and only a very gradual change to these low 60s dew points out along the Texas coast. If we dig a little bit deeper, we might even find a sea breeze through here. We would look at the satellite picture to find that. So here's the satellite photo from about 45 minutes ago. So part of what you do when you look at these satellite photos is you kind of resolve what types of cloud forms you're looking at. So we know for sure that this is an anvil, and that is too. But can we pick out any convective elements, like overshooting tops? We definitely do in here, and you can see gravity waves on the top of the anvil spreading out like that. So you see that up there. Same thing right here around, what's the name of that town? Guthrie. So we got this divergent pattern to the tops of the overshoots right there. So the heaviest cell is going to be right in that spot. And you might think you can go to the radars to kind of pick out where that is, but there's some parts of the U.S. that are not very well covered, such as southeast Montana. When I ran the Chase hotline, I think this happened about 12 years ago, maybe 10 or 12 years ago, there was a cell out there I was trying to keep track of, and the radars weren't really going out that far, so I was using visible satellite imagery to kind of keep track on where that updraft was and where the action was. So underneath, let's see, in this clear area, we've got probably some mid-level clouds. This looks like maybe altocumulus, maybe some high stratocu. So that's not going to be precipitation. But down here, there's some elements here that are probably going to be associated with some active storm activity. So obviously, we want to switch over to the radar, and I've already pulled up Fort Worth. And it doesn't look like much of anything. This is a pretty classic, maybe slightly high-based storms. And you can see there's a bit of an outflow. Spectrum width is very handy. I've pointed out that that's underused. And look how that stands out, that outflow boundary. Much more than on the reflectivity. So this is a tool that I use all the time. And I think if we animate this, we'll probably see those outflow boundaries pushing south. So there they are heading for DFW Airport. If you're at DFW, you'd probably be expecting a runway change in the next 20 minutes or so. So the Air Traffic Control Center forecasters are probably on top of that already. And there's a few other characteristics of the outflow boundaries you can pick up on. If you use the base velocity and set the cursor, let me move the window so you can see. So when I set the cursor on this outflow boundary and you look down here, you'll notice I'm picking up values of 22 knots outbound. So actually right here is what I'm looking at. The figure on the right is the maximum unambiguous velocity. So this is going to be about 25 knots outbound. That gives you an idea of what your gusts are going to be at the surface. Now, we are sampling the storm up at about 3,000, not the storm, but the outflow boundary. This is up at 3,000 feet. So we're slightly overshooting what's at the ground. The stuff at the ground is going to be a little bit weaker. But, you know, this will give you an idea of maximum gusts. If I'm seeing like 40 or 50 knots here, then I'm going to be concerned what's happening at the ground. But as far as this goes, I think people that are outside will probably barely notice the outflow boundary pushing through. And what else is going on with these storms up near, this is going to be northwest of Denton and west of Sanger and Valley View, Gainesville. If I go up to higher tilts, I can see that the intensities, they kind of die off as you go higher up in the storm. This is up at about 13,000 feet. Go up to higher tilts and the storms pretty much vanish once we get up to about 35,000 feet. And I don't see much tilt or overhang. So these are probably non-severe. The most we would get out of these is maybe some brief gusty winds, and lightning is always a risk. Okay, what else is going on in the world? We always want to pull up well, when I do this presentation, I like to see the national picture from the Weather Service showing all the watches and warnings. So these are going to be red flag advisories. Looks like the monsoon is kind of receded into the southern part of Arizona. So that's less of a factor right now. This is probably a heat advisory, and these are probably just some flood-related warnings. You remember we've got that frontal boundary laying through the southern U.S., so we're probably seeing some thunderstorms popping up this afternoon because of that. Okay, what do I want to go to next? Let's see. I was looking at some Russian stuff because I wanted to talk about Russia today because it's kind of like the Wild West out there. There's really no products. Like when I go to the Meteostar page and I look at their products. Let me go to that product page here. So say I want to forecast for Russia. Well, I've got good coverage of like Australia, definitely a Europe, but all I've got of Russia is this crappy Mercator view. And when you're looking at higher latitudes, that's pretty difficult to forecast off of. So let me go to the thickness here and you can get a look at that. We'll get this to freeze a frame real quick. Actually, let me center that real quick. Okay. So you can see everything is very distorted up in the northern part of the map. So this is not really ideal for looking at Russian weather. It's definitely usable. I can see there's a low pressure center here. Maybe an occluded front through here. Probably a cold front in here. Maybe a warm front in this area. So this is going to be just north of Mongolia towards Lake Baikal. And behind that I can see high pressure off to the west. So there's a storm system coming through this area which we're going to focus on because I'm going to show you the Aqua and Terra satellite imagery for that area. So let me zoom out real quick and you can see this area of Russia we're looking at. So we got China down here, Mongolia here, and then Russia up here. So this is the main area of weather action, and there's a couple pretty good storm cells right there. Those look pretty decent. I don't know how close we can get on these, and they're kind of upside down because the shadowing is on the top part. That's just the way the satellite has imaged the activity. But we've also got smoke here, so there's some forest fires going on in that part of Russia somewhere. And I had went to the Russian page. This is the Roshydromet page. I wanted to look at some of the products there, but I went through their links. I can kind of read a little bit of Cyrillic, and I couldn't find any maps at all. This is mostly just like government documents and stuff like that. So I don't know where they disseminate their products. If you guys happen to run across it, let me know, and we'll use some of it and kind of see what that stuff is like. So I'm having to use like Digital Atmosphere here. This is a map from about an hour ago, and this shows that area around Lake Baikal, which is right there, and here's that low pressure area. That area of thunderstorms we were looking at was probably in this, well, maybe a little bit further north of that, probably toward this cold core action here, because we've got dew points of 60, which is pretty high for Central Asia. As we get heating during the day, that area is going to become pretty unstable. So anyway, I don't want to get too much into detail. I might be boring some of you, but the idea is that there's not a whole lot of forecast products, so this is where you can really go to, play around and really sharpen your skills, because you have no help out there, but there's plenty of data, so you can really have some fun with that and look at weather in kind of an exotic location. And up there along the Arctic Ocean, slightly above freezing, so pretty typical for this time of year. Okay, let's go back to the US. Let's see here. I was trying to find products on the Roshydromet site, and I couldn't find any. So let me clear these away. So let's go back to our weather. Okay, once you're on the US pages, it's easy to find legible Lambert type charts, polar projections. So what does that show for us? Well, there's a cold core low over the Hudson Bay area, and I can see that's cold core because I'm looking at thickness here with surface pressure, and the thickness lines are pretty much parallel to the pressure lines, so that tells me that that's probably going to be a cold core system up there. And where they cross the pressure lines, that's where we're looking at advection. So you can see they form these boxes here. That's indicative of advection. And so what that means is that there's probably a front emerging out of northern Canada like that. And there's probably a warm front like that. So I can kind of use this thickness product to kind of keep track of the air masses and find fronts. That's one tool you can use. This is one thing we use mainly in the wintertime, during the cold half of the season. Not so much during the wintertime of the season, but in any case, you can see another cold air mass working on shore in the Pacific Northwest. That's going to be heading this way, at least towards the central U.S. in the next several days. And let me take you over to the 250 chart to give us a rough idea of the forecast. Okay, so we're starting out with this polar front jet across the western U.S. and a big ridge across the central U.S. So that ridge has given us a lot of the warm weather out in this region. And what we're expecting over the next week is this jet stream kind of sinking slightly towards the central U.S. So we catch the tail end of that, probably going to get a little bit of stronger storm activity towards the end of the week. And then after that, we're getting into next week. This looks like probably more of the same. Looks like we're going to stay under this high, that's going to mean a lot of warm weather for at least through the middle of this month. So that's not what I like to see, but we'll get to September eventually and start getting some more interesting weather here. Well, that's all I got for this time around. Man, we ran 20 minutes here. I appreciate you watching, and we'll see you tomorrow night. Thanks for watching.